Okay, number 66, that's a series problem, and looking at it, someone said, how would you do that? I think I'd probably use the ratio test, and I'm gonna go through that with you at the whiteboard, all right? These are more involved problems, and I wanna go to the whiteboard and write that down. So let me just write the problem down for you. This is number 66. Their question is, does this converge over here at n equals 1? And you might have suspicion about it, but we're gonna go through a test. So 4n, n factorial, and then you get n to the n. So what I'm going to do is I'm going to use what's known as, by the way, this is a positive term series. All right? I'm going to use the ratio test, though. So I'm going to write down the limit as n goes to infinity. Although the absolute value is not needed, I'll still write it down because that's what the ratio test says. It's going to be the an plus 1 term, which is 4 n plus 1 times n plus 1 factorial over n plus 1 to the n plus 1. Boy, this looks complicated. And then it's going to be divided by the an, which is like multiplied by the reciprocal. N to the n, and then 4 to the n factorial. All right? Got some work to do. I got to figure out this limit. And let's take a look. And I'm going to write down limit. N goes to infinity. The absolute value I can get rid of. Let's concentrate on one thing at a time. I'm going to concentrate on this first. And what do I see there? I see a lousy 4. That's about it. Whoops. All right. I am now going to concentrate on the n plus 1 factorial divided by the n factorial. And what does that give me? It gives me an n plus 1. All right. Now what I notice about that, I still have this problem over here, and I'm kind of looking at that. And it's going to be n plus 1, which is going to be n plus 1 times n plus 1 to the nth power. All right? I'm going to say these cancel off. Not bad. I got something that looks pretty easy there. And gee, let's take a look at that. That's going to be limit. N goes to infinity. And that's going to be 4. And then I'm going to write down, this is actually n over n plus 1 to the nth power. Boy, that does look kind of familiar, doesn't it? So I'm going to rewrite it so it looks a little more familiar, because it doesn't look what I really want to look like. And I'll write this over here. I'm going to write 4. I'm going to put the reciprocal down, which is n plus 1 over n to the minus n. Again, it still doesn't look familiar to me. I'm going to keep rewriting it. Limit. You could do L'Hopital's rule too, by the way. It is indeterminate. But I'm hoping this looks like something I've seen before. And right now I think I see it. So it's 1 plus 1 over n to the nth power. That whole thing raised to the power minus 1. Do I recognize this limit over here? Yeah, it's just simply a. So let's write this over here. I'm almost ready. As n goes to infinity, say. What do you get over here? It's going to be 4 e to the minus 1, which equals 4 over a. Now granted, if you have no idea what you just did, I want to go back and say, oh, it was a little while ago, wasn't it? We used the ratio test. And what did I just find? I just found that this thing is greater than 1. So what does it mean? The given series, this is the given series, is divergent. All right, let's go to the K, and let's see if they wrote that down. They put the limit down. Very little work, by the way, but they did write this over here, and it said the given series diverges. Make sure I put that down. Yeah, it's divergent. We're done. We're good to go. Thank you.